Okay, so for those who have not gone through the schedule, okay, here it is. So I think it's visible. So from 16 it starts, and on 16th you have your other subjects, and on 17th this morning, okay, we have kinematics and theory of machine. So we still have 10 more days to this particular exam. Okay, so in the meantime, what you'll do, what I suggest, those who have not started this studying, okay, you should start studying. Okay, so that you can do well in your class test. Okay, so up to the last class, anyone having any doubt, any confusion? Anyone? So I hope all of you have understood the things up to the last class, right? So in the last class, after the last class, the gear part actually we have covered. Okay, there are all those things related to classification of gears, the different terminologies that we use, the different nomenclature that we have, and similarly all those part of contact, part of precesing, like arc of contact. Similarly, all those contact ratio. What we mean by contact ratio? What is the meaning of this contact ratio? If suppose it is 1.4 or so, how can we define it? Okay. Similarly, the law of gearing, about the conjugate action of teeth. So, and the teeth profile, standard teeth profile, like the involute profile, the cycloidal profile, etc. And then some of the problems, like the problem of interference and undercutting with respect to your involute teeth profile, and how it can be mitigated, how we can avoid it. So those things also we have discussed later on. Okay, so that a gear as well as the pinion, how we can avoid interference, those things we have discussed up to the last class. And and we have discussed about the input of gears, and if a gear has been intersection, then what are the characteristics it should have. Okay, so all those this expression etc for minimum number of teeth to avoid interference. So those things also we have discussed, and we can put to use this equation, this expression, or these formulas in while solving the problems. Okay, towards the end of this class, I hope we'll be able to start solving some problems. So prior to that, what we'll do today, we'll be going through the next part, basically from this particular gear module only, which is nothing but we'll be discussing about gear train. Okay, so by this time, after the last class, basically, the gear drive, normal gear drive that we have studied, where we have seen that we have got a driver and a driven wheel. That means two gears which are in meshed, and one is acting like the driver, the another is acting like the driven or the follower. Okay, so that thing we have discussed. There already you have discussed about the central distance of the gear. Okay, so those things also we have discussed. So now, what is this gear train? So this gear train is nothing but a kind of, you can consider as if it's a higher version of the normal gear drive, whereby actually it's a combination of gears. So gear train, it's a combination of gears which is used to transmit motion from one shaft to another. Just like this is itself is the very primary application of your gear. Okay, so when actually it becomes very necessary so as to obtain a very large speed reduction within a small space. Okay, so the space constraint also is there. Then generally, by applying a combination of proper gear, which will be properly meshed and all. Okay, and the size etc. will be different. So based by considering proper this particular type of gear type. Okay, within a small space, actually we can get a very high reduction of speed. Okay, and a variety of speed reduction that we can achieve with the help of this gear train. Okay, and now why this word gear train is used? Actually, previously as we have seen, so two one gears which are in mesh, that is the driver and the driven gear, only about up to this much we have discussed. But sometimes what may happen to central distance, it may be somewhat more. Okay, next, apart from that, in a compact, sometimes it may also be necessary to get a variety of speed reduction. Okay, speed ranges within a small constraint. Okay, small space. And sometimes also it may so happen that just like in the case of your vehicles and all, where we have actually you say that we have engaged in the first gear, second gear, third gear, etc., etc. So basically it's a combination of different gears which comes into picture, which comes in mass while you actually change the position of that particular gear lever. Okay, actually different gears it engages, and in the vehicles and all, by changing the actually by engaging the proper gear sequence, actually you get the higher velocity and all. Okay, so actually what is responsible there in the case of your gear? Okay, whenever we say that gearbox is there, actually within that particular gearbox a particular type of suitable gear train is there, which holds the different gears of different size, different number of teeth, etc., in a particular position. And when actually you slide that particular whatever the gear lever that you have, actually by that actually, and by the proper engagement and disengagement of this particular class, actually you engage the required gear with the particular gear. Okay, so as to get a particular velocity ratio in your car. So now this gear train, okay, so depending on actually how the gears are being mounted. Okay, so how many gears are there, or like how the gears are being mounted on the shafts. Okay, and the way actually it is working and all, based on that the gear type also has got different like classification, just like the different gears that we have studied. Okay, so now what basically happens, so whenever we have this we use this particular word gear train, actually the gear train word that will be appropriate to use when we have a minimum three numbers of gears which will be in mass. Okay, so in the previous case, gear drive, we can have like we generally are talking about only the gear driven and the driver gear. Okay, but right now, whenever you'll be using the gear train, then we automatically mean that a minimum of three gears are in mass. So in that case, if you look at this particular first figure, okay, first animation, okay, the blue one, blue background one. So now in this case, actually, this gear train and as the simple gear train. So in this position, this blue
Sir, not audible
position, these
properly.
are the subs that we are talking about. Okay, okay, am I audible now properly?
Sir, your voice is like coming and going in between.
Okay, let me change the internet connection. Is it okay now?
Yes, sir.
Okay, thank you. So now in this first figure, okay, the blue background one, light blue one. Okay, so that is a simple gear train arrangement actually. Okay, where you can see actually you have this driver wheel. Okay, the left one, and actually the follower is some here. That means you want the motion conversion. Okay, transmit the motion up to this one. Okay, and you have an intermediate wheel in between. Actually, what is happening? So from this particular driver, okay, to this intermediate or the idle gear, actually the word is sometimes we use the intermediate gear or idle gear. Okay, which actually is not actually the driver is here driven, or the follower is actually here, and actually it is only acting like the intermediate gear and all. Okay, and it sometimes becomes the idle gear. So in that case, what happens on a particular shaft, on a single shaft a single gear is mounted, and it gets engaged with suppose this intermediate gear. Now if you look at this particular first part, then this is the driver and the intermediate becomes the driven. Now from the intermediate we get the velocity to this particular, or the motion transfer to this particular follower, and thus at the end of the process, actually this is the driver and this the last one is the actually is the follower or the driven. Okay, so that is simple gear train. That means where only one gear is mounted on a single shaft. And what is happening here? So these are external meshing or internal meshing. Can anyone tell me whether the gears are externally meshed or internally meshed? It's external meshing or internal? Yes, correct. So these are actually external meshing. So now in external meshing, so what happens if the driver is rotating in clockwise direction? So the driven will rotate in which direction? Driver is rotating
Opposite, sir.
Yes, opposite. That is the anti-clockwise direction. Correct. Okay. So that means, so if the driver is rotating in clockwise direction, this small gear, that is the idle gear, which is right now, if we consider only this first two, it becomes the driven. So it will rotate in the opposite direction. That is the anti-clockwise direction. Now this smaller gear which is rotating in the anti-clockwise direction, and can you tell me about the possible speed? What will happen to the velocity ratio? What can I expect? Suppose if the driver is rotating at suppose 500 rpm, okay, this driven, the smaller one, will it rotate faster or smaller? So basically that also we already know from the size and this perspective. So now this becomes a driver for, if you consider this one and the second gear and the third one, then the second gear, which is the intermediate gear, it becomes a driver. And now from here we'll get motion in this particular final follower, where actually our required motion transfer requirement is was there. Okay. And now if this is rotating now in anti-clockwise direction, now what, in which direction the third gear will rotate?
Clockwise.
Correct. So
Clockwise,
it
sir.
will rotate now in the clockwise. Yes, correct, correct. So it will now rotate in the clockwise direction. That means, so initial driver that was also rotating in the clockwise direction, and the follower, the final one, okay, that is also rotating in the clockwise direction. And this is how, as we have discussed in the very beginning, that means depending on the your requirement, whether in the same fashion, that is in the same direction of motion transfer you want to get, or whether you want to convert it to in different direction, based on that you can also utilize this way. Okay, that means intermediate gear actually it allows, one thing is the speed reduction or increase of speed, okay, that depending on your whatever is the requirement, okay, that can be obtained. That is one of the way, one of the you can say one of the things that it does, okay, this particular intermediate gear. Next thing, it also gives you the proper whatever is the direction of motion that you wanted. Okay, so right now if only you have only single intermediate gear in this case, just like in this case, so you can expect, suppose gear rotation in this particular direction. Okay, so single gear is there, and you have suppose four gears which are in one two here, and after that there is another one here, suppose. Then what will happen? What will happen to the fourth gear, which is meshed here at this end?
So it will be anti-clockwise again.
Yes, correct. So now once again from this clockwise, it will become the anti-clockwise direction motion, and that is how we can have a number of gears also. Okay, so this kind of arrangement is known as simple gear train arrangement. Okay, where on a single shaft a single gear is mounted, and just like in the previous cases, based on whatever is the velocity ratio requirement, you can play with the size and all. Okay, number of teeth and all. Similarly, we can have some other arrangement which are shown here. So here you can see in this particular figure, if it is evident in this particular figure. So suppose it is gear A, which is there, which is rotating. So next, in this location you can see, okay, on the same shaft actually gear B and gear C, two gears are mounted. Okay, and actually gear A is in mesh with gear B, the smaller one on this second shaft, and on the same shaft we have gear C, and this gear C in mesh with gear D. Okay, so this kind of arrangement also we may have, we may sometime one, okay, depending on the requirement of the velocity ratio at this particular location, as well as suppose like so what will happen here? So actually what's happening here is like from gear A to gear B, as they are in mesh, so some velocity or ratio, a particular velocity ratio will get, okay, and it is rotating in the anti-clockwise direction. So on the second shaft gear C is also rotated, mounted. So whatever is the direction of motion of gear B, gear C, as it is mounted on the same shaft, it will also rotate in the same direction, as well as whatever velocity gear B has obtained through this particular meshing. So gear C also will rotate with the same velocity. It is evident because it is on the same shaft. Okay, so now in the next run, the gear C will become the your this one. What to say? Your gear C will now become the driver for the next one. Okay, next one means the gear D, and depending on what is the type of whatever the size, number of teeth, etc., gear will get some extra boost. So this kind of arrangement where it's possible to have like a more than one number of gear, one gear, more than single gear on a same sub on the same sub. It's known as the compound type of gear arrangement. So similarly, in the third figure, actually we are showing a gearbox where we are showing the all those gears, different gears, the casing, etc., etc., which are generally evident in the vehicles and all. Okay, so now while analyzing this particular gear train and all, so whenever the driver and the driven they rotate in the same direction, so their motion will be taken with the same sign. Okay, that means positive sign, negative signs. While analyzing, we can utilize depending on if they are rotating in the same direction. Suppose if you consider driver as positive, so if the follower is also rotating in the same direction, you will be considering that also positive. Okay, and if the motion is different, suppose one is clockwise, another is anti-clockwise, the sign convention that will be using will be different. Okay, so this guarantee is easy only, but like the combination or the arrangement is somewhat different. Now there will be some words just like in the velocity ratio we have used in case of our normal gear drive. So in
Sir,
case in
sir,
yes,
sir, I have one question, sir.
yes,
Sir, can you please change the submission date of the assignment?
this is not a question. Okay, this is question
Sir,
is
actually means that day we have to submit another assignment, sir.
yeah done. So that's why I have given
Okay.
sufficient time now. You still have time. You still have I think 2 3 days. I think 2 days. I think.
That day we have to submit again one lab also, with mechanics lab.
Yeah. Mm-mm. So that way, like you have to manage your time. Okay, that's why all those things are being given there, given previously. Okay, so
Sir,
some of
if
your
you can,
friends they have also, it is same for everyone I think. Okay, and it's not only for you, it's for others also, they
sir,
have also
everyone,
to submit some others. Okay,
sir, everyone is
so
submitting
now
one.
we'll be going ahead with this particular topic, Samim. Okay, you utilize your, try to utilize your time properly, Samim, so then you should be able to get the speed up to speed ratio.
Yes,
Okay,
sir.
so you can also study that thing, it will be Samim. I think you try, you'll be 8th November is the date, I think. Today is 6. Okay, so we'll move ahead. Okay, so we'll move ahead with speed ratio and train value. So just like in the velocity ratio, we have the word speed ratio here, where speed ratio is given as the speed of the driver gear to that of the driven. And later on you will see it can also be obtained as the product of the number of teeth on the driven gears. Mind, we are using the word gears, not only gear. So there may be multiple driven gears. Just like in the previous case, we have seen suppose 4 gears if they are in mass, then one becomes driver. Suppose next one driven or so like that. Okay, and to the divide by product of the number of teeth on the driving gears. So that is how you can get the speed up speed ratio. And there is another word known as the train value, which is nothing but the reciprocal of speed ratio. That is 1 by speed ratio is train value. That is how they are related. And just like I have discussed previously, there are, depending on how it is arranged, how the gear train is behaving, we have a variety of gear train like simple gear train, compound gear train, reverted gear train, and planetary or sometimes known as epicyclic type of gear train. Okay, so what is this simple gear train? So in the previous this first slide itself, we have discussed about simple gear train. So this simple gear train. So here a series of gears which are capable of receiving as well as transmitting motion from one gear to the another gear. They are in mass, and this particular arrangement is known as simple gear train. Okay, so like all the shafts here, all the gears axes they remain fixed relative to their frame. Okay, and each gear they are mounted on a separate shaft, just like previously have discussed. In a single shaft, a single gear is mounted, and it is in matched with suppose next gear. That next gear is in matched with suppose gear 3. So gear 3 is now once again matched in matched with gear 4, and so on. Okay, And as we already know, as we are talking about external meshing, so two external gears of a pair, that means one and two, first and second gear, if we consider, they will always move in the opposite direction. If one is rotating from this gear in anti-clockwise sense, then two will rotate in the clockwise direction. If we next consider the second pair, two and three, it will, if two is rotating in clockwise, three will rotate in anti-clockwise, and so on. Okay. And always, if you like, depending on how many number of gears are there, okay, directly you can say a particular gear in which direction it will rotate. So if you know, suppose 1 2 3 4 5 6, like that, that many shaft, whatever is the number of gear, that many shafts will be there, because on a single shaft a single gear is mounted. Okay, so now what happens if you know about their numbering, suppose first, second, third, fourth, like that. Okay, then what happens here in the simple gear train, as they are externally meshed, so all the odd numbered gears will rotate in the same direction, and all the even numbered gear will rotate in the same direction. Suppose if one is rotating in anti-clockwise direction, ultimately number 3 gear also will rotate in anti-clockwise, number 5th will rotate in anti-clockwise. If there are number 7 gears, 6 and 7, 7 also will rotate in anti-clockwise direction, and so on. And similarly, all the even number 2 4 6 etc., they will rotate in the other direction. Okay, and here the arrangement may be, it can be on a, the gears may be on a straight line, just like in the previous first slide that we have shown. Three gears were there which were lying on the same straight line. Also it can be in a zigzag fashion, just like in this particular case. Okay, and how we can like get that, how we can analyze them, or get the train value and so. Okay, so what we can write, if we consider one a set of means a pair of gears. Okay, so for analysis purpose, what we can do, this simple gear train, it is nothing but we can consider as if we consider a pair. Okay, next this 2 and 3 another pair, 3 and 4 another pair, 4 and 5 another pair, then our job is done. Okay, very easily we can analyze it. So if one is driver, two is driven, two is driver, three is driven, and so on. Okay, that particular pair. So in that way, just like the from our previous knowledge, we'll be able to analyze it. So what I can write from our previous diagram, so n2 by n1, if we consider the first pair, okay, then I can write n2 by n1 equal to t1 by t2. That knowledge we already have. Similarly, second and third, if I consider n2 by n1, then I can consider like ratio equal to t. If gear number 2 will get, and T, that capital T, it represents the number of teeth which is there on this gear. So similarly, I can write, if I consider third and fourth pair, then the n4 by n3, it is inversely proportional to the number of teeth, that is t3 by t4, and so on. And if I multiply all of them, that is n2 by n1, then n3 by n2, the left hand side, if I multiply, I can equate to them to the multiplication of the all those right hand side. Okay, that is t1 by t2 into t2 by t3, and so on. And ultimately, what is nothing, the train value, how we can obtain the train value. So now if we look at this multiplication, this n2 will get cancelled, n3 will get cancelled, n4 will get cancelled, and what will ultimately remain, the final driven one, that is n5 by n1, it will remain, that ratio. Similarly, from this multiplication, this t2 will get cancelled, t3 get cancelled, t4 get cancelled, t1 by t5 it will remain. Understood? So now it is n5 by n1, it is nothing but the train value, the final one by the initial one. Okay, which we have obtained like t1 by t5. So what is this t1 by t5? It is nothing but the number of teeth on the driving gear, that is t1, and the number of teeth on the driven gear. And speed ratio, I can just write like 1 upon train value, so it is just the reverse. So what we have seen here, if we analyze, when we have analyzed this particular simple gear train, which have multiple gears mounted on a single shaft. Okay, so single shaft, a single gear on single shaft, and that kind of series of gears we can have in mass. So here actually the middle gears, the intermediate gears, that is that t2 3 4, they are actually not coming into picture when we are getting the train value, and so. Okay, if you look at from here, so only the first gear and last gear, that is there. So it has seen that the intermediate gears, they don't have any effect on the speed ratio, and therefore the intermediate gears are known as idlers or idle gear. Actually, what is their role? They are actually as if they are idle. Actually, they don't have any role role to play on this particular speed ratio. Only it depends on the first gear and the last gear, but they can give you the sense of direction. Okay, in which direction it will rotate, as well as they can give you positioning. Positioning means at what is the first location of the first sub, okay, and the last sub. Okay, that positioning can be maintained by using the intermediate gears. Okay, so is it clear? These are easy things only, just a series of gears which are in mesh. Is it clear, everyone?
Yes, sir.
Yes, sir.
Okay. Okay, thank you. So next we'll be discussing about the compound gear train. So just in the previous case we have discussed. So compound gear train, what happens here? If you look at these figures, actually these figures they represents different views. So this black and white kind of figure, they are similar kind of thing, and this set of figures, that is the bluish kind of figure, they are another set. Okay, which is representing actually two different gears in mesh, compound gear trains. Okay, so ultimately what happens for this particular case? So here you can see, just like in the previous case, first slide also we have discussed. So here, when a series of gears are connected in such a way that two or more gears they rotate about an axis with the same angular velocity, it is known as the compound gear train. That means two or more gear on the same axis and rotating on same angular velocity means, if we ultimately mount suppose two gears, just like it is evident in this particular figure. Okay, so this portion of this particular figure as well as in this particular figure. So here on the same shaft position, actually number 2 and number 3 gears are mounted. Similarly, in the same shaft 4 and 5 they are connected, and whatever is the, suppose if you look at in the figure, so number 1 gear it is in mesh with number 2 gear, the bigger one. It is not in mesh with number 3. Okay, so mind while drawing this figure, mind it. Okay, don't if you can have like this also, one is in mesh with 2, okay, and the other should be free then. So in that case you have to draw with dotted line in this particular zone. Okay, so that is possible, but only it is in mesh with only one, and depending on wherever you have meshed here, you have shown, so the next sequence also you should mind it. So what then it happens, one it is in mesh with 2, and depending on the number of teeth, the weight of the gear, okay, so it will ultimately become something like
Voice is gone, sir.
and the same. Yes.
Voice is fluctuating, sir.
Okay, okay. Okay, now is it okay?
Yes, sir.
Okay, thank you. So here in this particular meshing, one is in mesh with 2. Now 2 will get certain velocity, okay, depending on what is the size, number of teeth, etc. And 2 will rotate in a particular direction, depending on if the number 1 gear was rotating in anti-clockwise, 2 is rotating in clockwise direction. Okay, now as third gear is mounted on the same shaft, so third gear, which was actually previously not meshed with number 1 gear, that is the driver. Okay, but it will also get some velocity, same angular velocity as that of number 2 gear, because it is mounted on the same shaft, and angular velocity will be same as that of second, as well as the sense of rotation, that means the direction of rotation also will be same, because it is mounted on the same shaft. Now next sequence you be careful here. So next, number third gear is in mesh with number 4th gear, it is shown here. So while drawing, don't draw number 4 gear in mesh with number 2 gear, then it will have no sense, because it will ultimately become something like simple gear train, where actually third is having no role. It is nowhere mesh. Okay, so now this is in mesh with this, and we can still have a multiple number of gears which will be in mesh with which will be mounted on the same shaft, and so on. Okay, now here these figures they shows different representation, another view. Okay, number 1 gear in mesh with number 2 gear on the same shaft, we have third gear here, and third gear is in mesh with 4th. On the same shaft B, we have another gear, fifth is in connection with next gear and all, okay, in mesh and all. So this kind of combination is known as compound gear train. So here some of the intermediate shafts, it can carry more than 1 gear, one of which acts like a follower and the other as driven for the next step, okay, as evident from this particular figure. So similarly, same thing has been shown here in this particular figure. Actually, this figure and this figure actually, even though two views, they are not from the same thing. Okay, so that is the case. And here actually, we are showing the, like, for this arrangement only, it is the case. Okay, two views. So here also we are going to analyze this about the train value and all, okay, speed ratio. So for this case, once again, for analysis purpose, we'll be considering like a pair, 1 and 2, 3 and 4 and so on. Okay, so what we can do, if the gear 1 is the driver, then if we consider the first set, that is number second and number first, then N2 by N1 can be written as T1 by T2. Similarly, N4 and N3, if we consider the third and the fourth, we can write like N4 by N3 equal to T3 by T4. And so similarly, N6 by N5 equal to T5 by T6. And just like in the previous case, if we multiply them, okay, so then what happens? Will end up with, suppose you have multiplied here, and and we are ending up with N6 by N1 equal to T1 by T2 into T3 by T4 into T5 by T6. Now here 3 and 4 and 5 and 6 we are considering. Okay, 3 and 4 and 5 and 6. Why 3 and 4 and 5 and 6 as a pair? Because see, 3 and 4 are in mass, 5th and 6th gear in mass. Okay, which one is the driver, which one is the driven, you can very easily find out for this particular pair, and thus we have obtained this. Okay, and at last what we have seen, so the train value is nothing but, now it's a product of number of teeth on the which gears, the odd one, that is the T1, T3, T5. So they are nothing but the driving gears, and this T3, T2, T4, T6, there it is nothing but a product of the number of teeth on the driven gears. Why the odds are driven, and even one are kind of driven, you can say like driving and driven. Okay, you can say one, it is the driver, initially it is driver, two becomes driven. Now 3 and 4 combination, if we have, initially we have the velocity here, movement here in the 3, so 3 becomes driver, and 4 becomes driven. Now 4 and 3 combination, if we have, initially we have the velocity here, movement here, so 4 becomes driven. The same way
Sir, can
right,
you
they are the
explain
driving
again,
and
sir?
the
We cannot hear anything, sir.
which part.
Sir, from 1 to that one.
Okay, this is similar to the state of your simple gear train only, but right now the sequence is kind of, you can say, 1, 2 they have considered now, first and second as a pair we are just considering first and second. Now third and fourth they are in mass, and third wheel becomes the driver, fourth is driven. Now fifth and sixth are in mass, fifth wheel now becomes the driver, sixth is the driven. Up to under this much understood?
Yes, yes, sir.
Okay.
Yes, sir.
Next, what we have just considered as a pair, single pair, we have just considered 1, 2, 3, 4, 5, 6. And just like in the previous case, we have just written, we can write N2 by N1 equal to T1 by T2 in the reverse ratio as that of your teeth. Similarly, like N3 by N2 and so on. Okay, we have obtained. Okay, so here also, in case of compound gear train also, we can write in a similar way. Okay, N2 by N1, the set 1, 1 pair we have considered. Next, N4 by N3 can be written as T3 by T4 and so on. And if we multiply just like the previous case, at the end, this much we have obtained. That is the train value N6 by N1 is the product of the number of teeth on the driving gears. So 1, 3, 5th day becomes the driving gear. 2, 4, 6 they are the driven gear. So now it becomes the product of the things. Okay, previously in case of simple gear train, it was just the intermediate gear had no role to play, but in the compound gear train we have got the intermediate this one gears have some roles to play. Understood? That is what. I hope you have understood, right? Hello, am
Yes,
I
sir.
audible? Okay, thank you.
Yes, sir.
Okay, so the next type that we'll discuss is reverted gear train. So here, what is the reverted gear train, or when a gear train will be called as the reverted gear train? So as if you look from this particular figure, when actually the axis of the first, so here this is number one gear which is in mass with number two gear. This sub, on the same sub we have got number third gear, okay, and on after that we have got number fourth gear which is the last gear. Okay, so first gear is this number one, last gear position is this number four. Okay, and if you look at this particular axis, so this is the axis for number one gear, so from here to here it is number two gear, and this number third, number fourth. So when the axis of the first and the last gear, they coincide, so as like in this particular figure you can see, so the shaft for the last gear and the first gear, actually the axis of rotation for this gear, they're the same, they coincide. Okay, so this kind of setup, if it is there, it is known as the reverted gear train. Now from this figure, what we can write, if you look from this particular figure properly, so from here to, if you consider 1 and 2 and 3 and 4, actually the this is the sub position for this, that is the axis position, and for this side it is the axis position. Okay, so they are parallel, right? So it is parallel like this. So parallel means this much distance, this much distance is same as that of this much. Okay, so from this figure what we can write, so up to this much it is the radius of gear 1, from here to here it is radius of the gear 2, second, from here to here it is radius of the gear 3rd, from here to here it is the radius of the gear 4th. So what we can write, we can write r1 plus r2, which is this much, is equal to r3 plus r4, because the distance between the axis of 1 2, this first and second, and the third 4, it is same. So in terms of the radius I can write like this. Okay, it is addition of this plus this, this plus this. Or in terms of teeth also we can write, and typically it will become, so t1 plus t2 equal to, can be written as t3 plus t4. Okay, so the all those, whenever we are talking about gear, analysis of gear, whenever we are talking of all those radius or diameter, those are nothing but the pitch circle or pitch circle diameter, not of the etc. So those relative values are nothing, the pitch diameter that we discussed. Okay, if it is specifically discussed, suppose we are talking about random circle and so on, then it will be different. But in general, whenever we are talking of all those normal radius directly, if we are writing, or if we are talking gear radius or like that, then it is always the, we mean the pitch circle radius or the pitch circle diameter whenever we take that. Okay, so this kind of setup is known as reverted gear train, and it's used in different back gear of the lathe and different transmission mechanism in automotive blocks, etc. We have this reverted gear arrangement. Understood? So these are only based on
Yes,
the
sir.
actually how okay, only based on how actually they are mounted, what is the primary characteristics. So next one, another gear train we have, that is epicyclic gear train. So here in this figure, very simple form is only shown, where we have only two, we are showing only two gears. Okay, two gears in mass and connected by one arm B. Okay, if you look at this particular figure, so two gears, gear 1, gear 2, and on this particular sub, actually they are pin jointed and connected by an arm B. Okay, so what does this particular epicyclic gear train, and how we can identify them, and what is their characteristics? So here what happens, the axis of the gear wheels, they rotate about the axis of the other wheel, apart from or in addition to revolution around its respective axis. That means, what is the meaning of that? So here if you look at, so if you as this is being connected, gear 1 is there, if you don't consider the arm, then it is normal gear in mass, external mass. Okay, in that case what will happen, if gear 1 is rotating in the anti-clockwise direction, due to this massing, gear 2 is rotating in the clockwise direction. That is normal. But we also have this arm which is connecting the center position of this particular two gears, and this arm is given motion. It may be in anti-clockwise direction, clockwise fashion, and all. Okay, and because of that, what will happen? So if you look at this particular smaller wheel, so if I connect them with this particular arm, so here in the case of epicyclic gear train, the gear wheel, the axis of the gear wheels, they rotate about the axis of the other wheels. Okay, that means the smaller wheel, if you look at, so this smaller wheel is also rotating around this particular bigger wheel, apart from having its own rotation due to this meshing. Understood? So this way the gear itself will keep on changing the shaft position. Okay, it will keep on rotating in this particular direction. Okay, so both the revolution it has got. Okay, two types of thing. So it will rotate about the axis of the other wheel at in addition to the revolution around the respective axis. About their own respective axis, they will revolve at around the other wheel. It will rotate. Understood? So this kind of arrangement is known as the epicyclic gearing. And we can have more than two gear in phase. Okay, we also have another word known as sun and planet gear, which is somewhat similar to this epicyclic gearing only. Okay, so here if gear 1 is fixed and arm B, that is this arm, it is rotated about this particular center O1, then gear 2, what will happen to this particular gear 2? It is bound to rotate upon as well as around this one. Okay, now if we consider as if arm is fixed, this particular position is fixed. Okay, then what will happen? So both the gears will be fixed automatically and it will become simple gear train. Understood? And here this particular type of epicyclic gear train, which here in this particular figure, it's a very simple one, only 2 gears only we are showing, apart from the 3 gears, 5 gears, that kind of arrangement we can have. So here it is very useful for transmitting high velocity ratio, and it is used in different differential gears of automobiles, as well as in the back gears of LED, in the wristwatches and so on. Okay, and we have got another version of this, okay, also known as the sun and planet gear. Sometimes the same thing we use for epicyclic gear, sometimes sun and planet gear also is used, but there is a small distinction between sun and planet gear and epicyclic gear. So whenever if you look at this the mid portion, it is nothing but a kind of the we gear 4. Okay, so it is non gear or the wheel. Okay, when sun and planet gear. Why the name is sun and planet gear? Because the motion of these gears, these different gears, this arrangement, it resembles just like the sun and planet. So just like about around the sun, planets are rotating, right? Apart from having their own motion. So similar is the case, it becomes here. So this smaller gear, this is the planet gear. The center gear is nothing but the sun gear. So if you see about they are connected by this we have this arm here, okay, number 2 link, and during its course of action, actually this smaller gear 3, it will rotate like this also about this sun gear. Okay, around this sun gear it will rotate just like a planet. That's why this gear is known as the planet gear, the central gear is the sun gear. Okay, and within the annular wheel or the bigger wheel, which around about which it is there, it is known as the ring gear. Okay, and this ring gear or the annular wheel, it has got internal teeth cut here, and they have got external teeth. So the external teeth from this particular smaller gear, the planet gear, will be enmeshed with the internal teeth with the ring gear. Okay, understood? So then we'll be calling this epicyclic gear train then as sun and planet gear. Okay, it's a special case of epicyclic case. I hope understood. You have understood?
Yes, sir.
Okay, so these are the main variety of different gear trains. So now we'll just see some how we can analyze this epicyclic gear train. So as we have said, So actually during the analysis of epicyclic gear train, so we'll just consider some condition of motion. That means which particular link is fixed, that is gear 1, gear 2, or whether the arm, etc. And we'll try to see, depending on how many number of gears are in connection, how many arms are there, okay, based on that what kind of motion it is getting, we'll try to see, and that is how we analyze it. Okay, so here in for our analysis purpose, we just make a chart like this, where we show the condition of motion and what happens to the different elements, what happens to the motion of the different elements, that will just show. Okay, so how many elements we have? So we have got the two wheels, gear wheels, wheel 1 and wheel 2, and we have got the arm here. Okay, now first condition, if the arm is fixed and we are giving one complete rotation in the clockwise anti-clockwise direction, which is considered as positive, to wheel 1, then what will be the condition of motion to the other wheels? So if the arm is fixed, what will be the motion of the arm? 0, right? Can you follow me? Motion of
Yes,
the
sir.
arm. Yes. Next, what will happen to gear 1? I have already said that wheel 1 is rotated through +1 revolution in the anti-clockwise direction. So wheel motion of wheel element is +1. Now, because of this, what will happen to the wheel 2? If you look from this particular figure, so if wheel 1 is rotating in this direction, it is completely rotated by one angle, one revolution, then wheel 2 is bound to get some motion, right? And as it is externally meshed, so in will it rotate in the same direction, wheel 2, or in the opposite direction?
Opposite.
Correct, it will rotate in the opposite direction. So we have to consider negative sign, because the other one we have already considered positive. Next, the opposite direction we will consider negative. And how we can get the motion, it actually, we know it depends on the number of teeth. From there also we can get. Okay, so what we can write, the motion of the wheel will be, it will be minus t1 by t2. Okay, so t1 by t2 will give the motion of second element. Okay, so next, if we consider the condition, suppose arm is once again fixed, and now we have given more number of revolution to wheel 1. Okay, previously only one revolution, +1 revolution. Now suppose plus x number of revolution that we have given. So now it will be just changed by plus x, and that x number of revolution will be that x will be multiplied here. Understood? Can you follow me?
Yes, sir.
Kind of, you can consider previously one plus x multiplied. So now if we consider, suppose arm B is also given motion, which is generally is given. Okay, arm B also is given. So total motion what we will get? So this motion of the arm B, whatever motion we get to the arm, if it is given, okay, same motion will be as it is connecting a first wheel as well as to number 2 wheel. So the motion will be added to all the elements if we give motion to arm, right? So that is what has been written. If we add y, that is the motion of the arm, to all the elements, so total motion will be just, it will be added, y will be added. So 0 plus y, it is y, x plus y, it is y. So this mass plus y, that can be written as y minus this. Okay, this minus of this plus y. So y we have written initially, y minus this. Okay, understood? So this is how we analyze this. Okay, so later on we'll be solving some problems of epicyclic gear train. Then sequentially, one by one, you can keep on doing like that. Motion of this element, next because of this motion, what will happen to the other element, like that. Understood? Okay, I hope you have understood. So the very last topic from this gear train and this more particular model is, we'll be talking about torques in epicyclic gear train. So generally the gears in case of epicyclic gear train, they are moving with uniform speed. So because of that, no angular acceleration is there. Okay, and what will happen to the gear train? It should be in equilibrium, and it is in equilibrium under the influence of these three external torques. So what we have? What are the different torques we have? So the driving torque or the input torque, which is given to the driving wheel, and the output torque that is there on the driven element that will be there, and a fixing torque or a resisting holding torque is there. Okay, so which will not allow this particular driving and driven element to fall apart. Okay, so under this torque, three torques, okay, so it will be in equilibrium. The whole train, gear train, will be in equilibrium. That means we can write the addition or the summation of all these three torques, the driving torque, the input torque, output torque, and the fixing torque, equal to 0. Or torque we can write like that, f into r, that is the radius, and the this one gives us torque. Okay, we can already know. Okay, fr gives you torque, so we can write for the first one f1 r1, like, and for the second one f2 r2, and so on. Okay, and that is r1 is nothing but the corresponding radii. Okay, r1 r2 r3. And like if we also neglect the like energy of the gear train is 0, if all losses due to friction etc are neglected, then also the similar kind of thing. Okay, we can multiply in terms of right, in terms of this one. Okay, omega also. So f equal to the t omega, we can write like that. Okay, and addition of them is equal to 0. Okay, so if we consider the fixed element, so fixed element means itself is 0. So the fixed element, for fixed element omega 3 will be 0, then only the other two element will remain. So this is how that, like, basic thing is here. That means the whole gear train is in equilibrium under the equilibrium of these three torques which are there, which are present there. Okay, that is what you should know. That is what is the gist of this particular whole slide. Understood? So the addition of or the summation of all these three torques, it is 0, and that is how we get the equilibrium. Okay, so with this, actually the theory part from this module we have covered. The whole thing is over. So from the next class onwards, okay, we'll be solving some problems from gears as well as from gear train. So we'll be analyzing gear train. We'll be going to finding out, suppose, all those contact ratio, etc., etc., that kind of problem and all. Okay, so with this, we'll stop here. If you have any question, you can ask. And if you have understood or not, have you understood or not, you can let me know your understanding level.
Understood, sir.
Okay, thank you. So yes, Naransi also understood. Okay, I hope others also have understood the things. So with this, we'll stop here today. So thank you everyone for joining, and we'll meet in the next class, and we'll solve. Thank you everyone. So
Thank you.